Okay, let's continue with the problem of chapter 1. The problem 1.20a subdivide the region in figure 1.19c in a match of squares of sides a over 2. Terminate the region on the right, a distance a from the corner, and on the left, a distance 3a over 2 from the corner. Take b equal to 2a, this is your b, and v0 equal to 100, this is your v0, 100 volt. Consider the potential at the left and the right edges of the above defined grid to be fixed at the values found in a linear variation from top to the bottom. Start with all interior grid point at 50 volt. Okay, so we're going to initially we're going to assume V1 to V8 are 50 volts. Find the potentials at the match points, assuming zero space charge and applying the simple averaging method. So this is your plane, and you have the potential along the edge as in the figure. So we are looking for the potential at each match, which is the V1 to V8. Okay, from the problem, we're going to apply the iteration method. What does this mean, iteration? Iteration is mean that you start with some number of potential. In this case, we start with V1 to V8 equal to 50 volts, and we're going to do calculation until the voltage doesn't change much. So that's going to be the final potential at each point. So let's start with equation 1.24 with rho equal to 0. That's defined, for example, 4. Okay, we pick up this point V1. 4 of V, that's going to be equal to the average of the potential around the point. So that's mean for phi of xy equal to 4x plus h, where your h equal to a over 2, right? This is the length of 4a, and divide by 4, that's give you h, the height, to be a over 2, and then you plus the potential at this point, plus the potential at this point, plus the potential at this point, and when your rho, the charge density equal to 0, so you have only this equation. So sorry for the first iteration, you have a phi xy going to be equal to what? You start from phi 1, that's going to be 100 volt, right? Let's do a counterclockwise. 75 volt and your phi 2, phi 3, that's 50, right? Because we assume that initial voltage of interior match point equal to 50 volt. And then you go to phi 2, which is the 50 volt. You end up with your phi 1 equal to 68.75. Same as phi 2. That's going to be what? Phi 1 plus 50, right? Plus phi 5. This is your phi 2. Phi 2 going to be equal to 100 plus phi 1 plus phi 4 plus 100. And your phi 4 equal to 50 volts. You have phi 2 equal to 75 volts. What about phi 3? Phi 3, this is your phi 3. Phi 3 going to be equal to phi 1 plus 50 plus phi 5 plus phi 4, right? And phi 4 and phi 5 equal to 50 volts. So you have phi 3 equal to 50 volts. Phi 4, that's going to be equal to phi 2 plus phi 3, 50 volt, plus phi 6, 50 volt, plus 100 volt. And you have phi 4 equal to 62.50 volt. And you can do the rest. And also do the second iteration. Actually, I don't have it here. So in the case of the second iteration, you do the same way. So your phi 1 going to be what? 100 plus 75. But now you need to use phi 2, phi 3, not 50 volt anymore, because you already have phi 2 equal to 75 volt. You need to put phi 2 equal to 75 volt, phi 3, 50 volt, and then phi 2. What is your phi 2? You need to put 75 instead of 50 volt. Okay, so that's how to do the second iteration, and you go on and on. And I have summarized, phi 1 to phi 8. This is your first iteration, the second, the third, the fourth. You can see the number change. Start from 50, right? Phi 1. And then for the first iteration, you have 68.75, and then 75, 77.74, and then 78.71. That's going to converge to a number that's going to be your final potential. Now, alternately, we can also write a set of equations in matrix form, and so without regards to initial value, or we assume that our potential are 50 volts. So you need to set equation. That's straightforward. Let's get back to the previous page. Well, to average, you have phi 1 equal to 100 plus 75 plus phi 2, phi 3 plus phi 2 divided by 4. That's going to be the first equation. Since you have 8 unknowns, So you need the equations, which I wrote down right here. So you have for phi1, you have for phi2, and you set up a matrix to solve for phi1 to phi8. Okay, so this is your equations, matrix form. You have phi1 to phi8 equal to 175. This is just a constant number. And you can work out this one. This is what? 8 by 8 matrix. So your B or your phi equal to inverse matrix of A, or inverse matrix of this matrix to C. This is your C. And finally I have phi1 equal to 80.67, phi8 equal to 45.14. So that's how you find the potential at each match. For the problem 128. Okay, we move to the next problem. Oh, sorry, this is the same problem. I show you to do the second iteration. Okay, so you need to, this is your phi2, sorry, phi3, phi3 and phi2, and you need to continue do iteration until values do not vary much. The problem 1.20b repeat problem 1.20a using the cyclic Chebyshev method. Okay, we work out on the same problem to find the potential at each match, phi1 to phi8. Well, let's review the cyclic Chebyshev method. This is your phi, the potential at each point or each match. It's going to be equal to the previous potential, or let's say the second iteration you need to pick up the potential from the first iteration plus omega r over 4. What is omega? Omega is relaxation factor divided by this equation. Omega 1, the first iteration equal to 1, and the second iteration, your omega equal to 1 minus 1 over 2 eta it to the power negative 1, and your omega of k plus 1 iteration equal to 1 over 1 minus 1 over 4 omega from the k iteration multiplied by eta it, where your eta it equal to 1 over 4 cosine pi m plus cosine pi n. And this is your r, because you need r for potential calculation. Your rk, the kth iteration equal to phi that point at x and y plus h. Okay, you have a phi here, right? So you need to pick up this one, pick up the potential at this point, potential at this point, and potential at this point. So around that potential point. And let's go back to your omega. Now take m equal to n equal to 3 for simplicity, and assume 54. That's the zero iteration, or the at all points initially your eta it is equal to 1 over 4 cosine pi over 3, which is the 1 over 2. So you have eta it equal to 0.25. Now you'll be able to calculate for omega, the second iteration, by applying this equation. So you have 1 minus pick up this one. 1 minus 1 over 4 multiplied by omega, which is the 1.1429 multiplied by eta it, which is 0.25, and divided by 4. That's give you the second iteration. The second iteration. This is the third. It's going to be 1.0769. You do the same thing for the fourth iteration. Your omega equal to 1.0721. Now we are ready to do the calculation. Okay, let's start with the first iteration. Your phi k equal to u phi k minus 1 plus omega k r k over 4, where your r equal to phi k x y plus h plus phi k x plus h, and so on. Since your rho equal to 0, you don't have this term. This term drop. You take a look. You're looking for your phi xy. That's going to be the average of the potential around this point. Now we're going to apply this equation. Phi k equal to phi k minus 1 plus omega k r k over 4. Phi 1. Initially we set up our potential at each point to be 54, right? So your phi 1, you start from this. It's going to be equal to 100 plus 75 plus phi 3 plus phi 2. We start with the phi 3 and phi 2 equal to 50. This gives you phi 1 68.75. And you can check back from this equation. Your phi of the first iteration equal to the phi of the zero iteration plus omega from the first iteration, and r of the first iteration divided by 4. For the first iteration, you know that your omega equal to 1, and your r from the first from the first iteration equal to, okay, you don't know yet, so we are going to find r from the first iteration, which is you pick up this equation, and then r1 of the first iteration going to be a phi 1 from the first iteration. Okay, and r1, as we have pick up from the picture here, become 100 plus phi 3 plus phi 2 plus the $75. Okay, this is 75, a little bit confused. And you have feet 2 and feet 3. And you use the feet 3 as 54, feet 2 as 54. So minus 4 of phi 1 from the 0 iteration, which is the 54. You end up R1 equal to 75 volt. Now you're looking for phi 1 by applying this equation. You have phi 1 going to be equal to phi 1 from the 0 iteration plus omega 1, which is 1, and then multiply by R1 divided by 4 to get phi 1 for the first iteration becomes 68.75, same as you do calculation here. Now what about phi 2? You need to make a move. Your phi 2 from the 0 iteration is the 54. So your R2 become what? This is your phi 2. That's the relight. Phi 2. You have phi 2 here above phi 2. This is 100 volt, right? And on the left of your phi 2, that's the phi 1, which is you pick up phi 1 from the previous calculation. And down below, what's that? That's the phi 4, right? We don't have phi 4 from the first iteration yet, so we put phi 4 as 54. And you're back to the right of your phi 2, which is the 100, and minus 4 of phi 2 from the 0 iteration. So that's the start with the 54. You end up with R2 equal 118.75 So your phi 2 equal to phi 2 from 0 iteration plus omega from the first iteration multiplied by R2 from the first iteration divided by 4. 54 is the phi 2 from the 0 iteration. Omega from the first iteration is 1, and this is your R2, 118.75 divided by 4. You end up with phi 2 equal to 75.694. This is your phi 2. You probably have an idea how to do the calculation already, so I keep working on phi 3, phi 4, phi 5, phi 6. Okay? It shouldn't be so difficult for you to understand, the process of calculations. This is the first iteration. What about the second iteration? Here's my second iteration. You do the same thing. Your omega equal to 1.1429, and phi 1 from the first iteration is the 68.75, and your R1 of the second iteration, that's going to be this is your phi 1, right? The above is 100 volt, on the left is 75 volt, at the bottom that's the phi 3, on the right is the phi 2, and minus 4 phi 1 from the first iteration. Now you need to use the phi 3 from the first iteration, which is the 54.65, and phi 2 from the first iteration, which is the 79.69, and that's give you R1. Then your phi 1 of the second iteration going to be phi 1 from the first iteration plus omega from the second iteration multiplied by r1 from the second iteration divided by 4, and this is your r. So you end up with phi 1 of the second iteration equal to 78.57. You can do for phi 2, you can do for phi 3. So I summarized, all the values from each iteration. So this is my first iteration, this is my second, my third, my fourth, and it can go on. But you can see that the number, doesn't change much. You can stop with the fourth iteration. So these numbers too of behind, right, from 1 to 1.14, but this is 1.07. This is also 1.07 from the fourth iteration. Phi 1, we all start with the phi 1 to phi 8. I put this one as the 0 iterations. They all are 54s. This is from the first iteration, the second iteration. Okay, you can practice, then you can work out again, check by yourself. So this are for the problem from chapter 1, and we still have more problems from chapter 1, which I will continue in the next series. Okay, bye.